normally simply learn it and remember it and just follow it without figuring out whether this thing is wrong or right. So probably I think you should be able to build those skills while going through this all the talks, discussing. So have a lot of discussion as far as possible. It's not only just listening to the people. Don't be a passive listener. Be a participant. It happens to a great extent when it is in offline mode, but even in online this can be done. You have to essentially become a kind of you have to be aggressive on this aspect. So please do that, and so I wish all of you a good, I think, is a 4 or 5 days of thing, and then go through all the talks, discuss, may prepare your notes, even share later on. I think with the organizer, he can compile all your notes and then probably kind of share that PDF with everybody. This will also become a good record for the library, for all the institutes where all of you are there. So with all that, it's my best wishes. Please make the best use of this opportunity. And thank you, Manoj, for introducing me. So with that, I think over back to Manoj ji.
थैंक यू सर। आपसे बहुत दिनों के बाद देखने का मुझे सौभाग्य मिला। बहुत अच्छा लगा, बहुत अच्छा लगा। मैं अपनी दिल की प्रसन्नता शब्दों में नहीं बयान कर सकता। आपसे इंटरेक्शन करके, आपसे मिलकर, आपसे बातचीत करके हमेशा मुझे अच्छा लगा है। आप बहुत दिल के सच्चे व्यक्ति हैं और बोलने में भी उतने ही स्पष्ट हैं। बहुत अच्छा लगता है सर आपसे बात करके। मैं उम्मीद करता हूँ निकट भविष्य में हम आपके दर्शन कन्नौज में भी करेंगे, तो हमें कम से कम मुझे बहुत अच्छा लगेगा। औरों की तो मैं बात नहीं करता, लेकिन मुझे बहुत अच्छा लगेगा। तो मैं चाहूंगा सर एक बार आपके दर्शन मुझे कन्नौज में भी मिले।
जरूर जरूर।
धन्यवाद सर, बहुत अच्छा लगता है। आप वाकई बहुत अच्छे व्यक्ति हैं। ऐसे व्यक्ति ज्यादा नहीं है एकेडमिया में, इसीलिए मैं आपका बहुत सम्मान करता हूँ सर।
थैंक यू
सर। डॉक्टर अरुण प्लीज।
हाँ सर, प्रणाम। सर से मैंने सोचा था कि मैं पहले सर को इनवाइट करूं। बेसिकली ये एफडीपी 2 बार पोस्टपोन हुई ड्यू टू लेस नंबर ऑफ पार्टिसिपेंट इन दिस पर्टिकुलर टॉपिक। ये स्पेसिफिक टॉपिक था तो इस एरिया में कम लोग इनरोल कर रहे थे। जनरल टॉपिक रहता तो इसमें बहुत पार्टिसिपेंट हो सकते थे, लेकिन ये था कि राजीव का इंसिस्टेंस था कि नहीं सर इसी टॉपिक पे कराना है, तो हमने कहा ठीक है, मैं सर से बात करता हूँ, आप कराओ इसको। तो रिसोर्स पर्सन इंडस्ट्री से इसमें 8 लोग हैं सर। एकेडमिया से केवल 5 या 6 लोग हमने रखे हैं, सभी हैं। उसमें एक अच्छे राठौड़ जी हैं जो कि पावर मैनेजमेंट वाले पे बात करेंगे। उसके अलावा मनीष तिवारी जी हैं जो कि फिल्टर डिजाइनिंग, हाई फ्रीक्वेंसी, इन सब पे बात करेंगे। कैसे कि ड्रोन टेक्नोलॉजीज के लिए फिल्टर्स को डिजाइन करते हैं, कम्युनिकेशन में उसको कैसे यूज कर सकते हैं, उस टॉपिक पे उनका वर्क है, इस पे वो काम करेंगे। अरुण प्रकाश जी हैं और एक सौरभ दीक्षित जी हैं जो कि उसमें सिक्योरिटी फीचर्स के बारे में बात करेंगे। पहले इन्फोसिस में थे, वो किसी और कंपनी को ज्वाइन किया है। और विपिन बालियान जी भी हैं जो कि इस समय साउथ अफ्रीका में है। तो 2 फॉरेन के स्पीकर्स हैं और रिमेनिंग इंडस्ट्री पर्सन है। तो एकेडमिक से केवल 5 लोग हैं सर। तो इसीलिए हमने कहा था कि आप रहेंगे तो जरा उस चीजों को पूरा समराइज करके कि रिसर्च किस तरीके से तो ठीक है सर। फिर मैं जो भी लोग हैं उसको उसी हिसाब से प्रोसीड करेंगे। मेरा तो केवल ये था कि आपके दर्शन हो जाएंगे जैसे सर ने कहा, तो अच्छा रहता। मैं मिलने आऊंगा नहीं, मैं अगले महीने ही आपको कन्नौज में आमंत्रित करूंगा, खुद ही लेने आऊंगा सर।
जरूर।
और उम्मीद करूंगा आप उसको एक्सेप्ट करेंगे। नीलम मैडम भी हैं, क्योंकि मैंने आज उनसे सुबह ही कहा। मैं पहले से इसलिए नहीं कहा था कि हमने कहा कि उस दिन देखेंगे कौन अवेलेबल है, उसके हिसाब से रिक्वेस्ट करेंगे। ऑनलाइन है तो जो अवेलेबल होगा वो ज्वाइन कर लेगा। तो मैडम ने जब एक्सेप्टेंस दे दी तो हमने कहा ठीक है मैम आप आ जाइए, अच्छा रहेगा। तो उन्होंने कहा कि स्लाइड बनानी है लंबी, हमने कहा नहीं, इनॉग्रेशन में आइए, स्लाइड के लिए हम फिर आपसे अलग से करेंगे। थैंक यू मैम, आपने ज्वाइन किया। अब मैं राजीव से कहता हूँ कि आप प्रोग्राम को प्रोसीड करें, क्योंकि इनॉग्रेशन हम लोग आधे घंटे का, उसके बाद फिर हम लोग सेशन स्टार्ट करेंगे।
गुड इवनिंग एवरीवन। जो टॉपिक लिया है जैसा कि बताया अरुण सिंह ने और मैंने देखा भी, इमर्जिंग ट्रेंड इन यूएवी एडेड नेक्स्ट जनरेशन वायरलेस नेटवर्क, मेरे ख्याल से आज का सबसे इमर्जेंट टॉपिक है। क्योंकि अब तक तो हमने जो व्हीकल्स थी, ड्रोन्स जो थे, उनको खाली एंटरटेनमेंट में देखा था। मतलब शादी में ऊपर नाच रहे हैं वो और फोटोग्राफी कर रहे हैं, और यहाँ हमने उनको उसमें डिफेंस में देखा था, दैट फॉर रिमोट थिंग, वेदर something we want to have track something in coal mines or something in jungle. For those cases we used to use drones. The latest war which we not saw on the TV, that was totally dependent upon this drone technology. So it is the most emerging topic of today, and because we are moving from 5G towards 6G, so naturally first we talk of single unit and then we talk of network. Like when the computers come, we talk of solo computers, then we come to the LAN networked, then phone came, we have wireless networks. Now we had networking in each and everything, internet of thing, which is talking of networking each and everything, industrial networking. So this drone network is going to play a very important role for commercial applications, for defense applications, as well as for so many things which are going within the city in very small area. For example, if you talk of traffic management, which is very important nowadays. In the evening vehicles are not moving, so in that case also the network of drone can I mean make the ad hoc network and give you the best possible route in the real domain. So domain, these drones and unarmed vehicles, they are basically used for uh, real domain technologies. Like they can make us they can choose a small area, they can make a ad hoc network and they communicate with each other. They follow all those features which any traditional network is having, but they are making in a very small thing, and they are very fast. So that is the beauty of these networks. And they make use of AI, as we are listening that AI is doing I mean wonders in our day to day activities. So they are also I mean make use of AI and ML to make it more and more useful for the common society. So in this 6 day seminar, as it was told by Arun, that many industrial professionals and academia are going to come and deliver their expertise in this particular area, which is of very interesting topic of today and tomorrow. So my best wishes to all of you for the successful conduction of this FDP. A big thank you firstly to Arun Singh to connect with me to my college. I always feel happy to connect with REC Kannauj. So thank you Arun for connecting me for this FDP. And as Professor Singh told me, we know each other since last 20 years, you and Manoj also. And I'm very happy that when I was director, I was calling Manoj as guest in various FDPs and other activities. And now Manoj is calling me. So vice versa, है ना, दुनिया गोल है. So वो यही दिखती है गोल गोल. So a big thank you to you all. And listening to Professor Singh is always very useful and very important. So thank you, Professor. With these words, it's a inaugural event, so not many thing about this technology. Uh, my best wishes to all the organizers, and my best wishes to all the faculties who are attending this FDP. Hope you will learn a lot in this 6 day program. Thank you so much.
Thank you, ma'am. It's really nice to see you on the screen. And madam, these positions are only temporary. Once you were on the chair, now I am. Sometimes other will be on the chair.
Yes,
These
yes.
are temporary, but the thing is that we have to communicate with each other always, and we have to learn from each other, from
Yes.
our seniors, from our juniors, from everyone whoever can teach us something. So in this
Yes.
regard, this FDP, in fact, in faculty development program, we all are going to be developed in terms of our knowledge enrichment. So I hope that this FDP will be very much successful. Thank you, madam. Thank you.
Thank you, ma'am, for sharing a valuable time. It is now time to proceed to our first main session and invite our chief guest and keynote speaker, Dr. Yatindra Nath Singh from IIT Kanpur, to address the gathering and share his valuable insights. Sir, we are privileged to learn from you.
So thank you. I have not made any PowerPoint, as this is actually not my core area. I have not been working on UAV communications, UAV assisted communications actually. So in fact, Rajiv only told me that there has to be a talk, and that's it. And later on, I discovered that there is also a topic being given, but that's also not my expert area. My students were there; I have learned something from them. So I thought maybe I will keep it as an interactive session. So please do stop me at any point of time if you have doubt, because I have seen that people actually do have a lot of misunderstandings about wireless communications or optical communications, whatever it is. So, but what I would love to essentially share with all of you is a different philosophy, which of course is not very prevalent in India, but probably can make a lot of difference in the academic institutes. All of you actually belong to academia.
This is integrated with
Yeah, there somebody was saying something. Was there any question or comment? I can actually pick up from there. Then I don't have to think what I have to talk. Okay, so what I actually, instead of being in wireless communication, I am actually going to talk about philosophy, that how the research can be done in another different paradigm. Okay, so one thing which is very important, that a lot of us think research actually means just doing some simulation, writing a paper and publishing. Okay, and that's it. So you count the number of papers on your CV and be happy with that and say I am a great researcher. No, that's not research. Okay, that's not the way the Feynman has done it. That's not the way the Newton did it, or that's not the way the Einstein did it. Okay, research is still the same, whoever has done it, and we all can actually do it the same way. Of course, we all may not get the Nobel Prize. Uh, so remember that everybody who gets the Nobel Prize is a great researcher, but all great researchers will also not get the Nobel Prize. So there have been so many that who never got it. So we should not worry about rewards or awards. We should worry about what work we actually do. So now what the research is all about. So first of all, I will talk about that, and then how I started experimenting in my laboratory. In my lab, I created a structure where doctoral students need not bother about writing papers, first thing. They need not bother about looking for an academic position once they graduate out. Because why people want to write paper? Because that paper count will ensure that they will get shortlisted when the selection committee is going to happen. Okay, or when they are going to apply for a postdoctoral position. But if I can make a system whereby when a person joins for a PhD, automatically also gets into a job, there is nothing better than that. So that actually means we have to create an industry, essentially. So the way I am going to tell this whole story. So this is independent of the topic of the FDP, but this is very general, very relevant to everybody. You probably can ponder and think about it. And there's not been one but many success stories, but not in India. India probably we are the first one who are trying this particular model. Now the idea here is very simple. Okay, that as a one single person, you probably cannot do much. You have a very narrow expertise once you finish your doctorate or whenever you are finishing your studies, because that's a small experience which you go through in your life. You actually gain that very narrow expertise. With that, if you want to now build up a product or provide goods or services to somebody so that you can get the money. Remember, any business is nothing but it takes in raw material, takes in labor, and then creates what we call some goods or some services, which are then sold off to some customer, and then customer pays for it. Okay, and then you try to minimize the payment to the labor and for the raw material and try to maximize your profit. That's a conventional business model. That's the way it has been taught to everybody. I thought of an alternative way. One thing is that single person does not have the expertise. Now, if you can actually have collect a lot of people together, maybe your friends, each one of them will have a different expertise. Now, when you all together try to build up a product, the possibility that you are going to build it is going to be much higher, because you start compensating for each other's deficiencies. Okay, we cover up each other's deficiencies actually. This is what you call cooperation. So this does happen in biological systems also. You can actually see in nature. This is natural phenomena. So we have only two things: cooperation and competition. Okay, but unfortunately in our academic systems, we have been from childhood. Even a brother and sister will also be competing. They will not be cooperating. When you are in a class, you again compete. You never cooperate. As a faculty, you start competing with each other. You never cooperate. Okay. Uh, that's a very bad part, because then you actually end up in working silos. You don't you don't cooperate. Now, problem why the cooperation does not happen is something called free riding phenomena. Okay. So people will always have a fear that I am going to do a lot of work, the other guy will not work, and he will end up in getting the benefits of that without working. As a consequence, cooperation does happen. People do cooperate, but they will be always like-minded people. Okay. So, or equal capabilities. A differential capability cooperation generally does not happen. So this is a natural thing, but there is a formalism where it is actually is feasible. So why I started on this is some 2.5 years back, some of my students, well, I was also kind of very, I was not very comfortable, because a lot of my students who were taking a lot of time in graduating, they were using 4.5 years, 5 years. And then what happens is their fellowship stops, and then they were without money. And then they're always worried. I am always emphasizing on research, not on papers. Papers comes as a consequence. These are byproducts. They say, sir, we don't have transaction papers, and so we have to do this, but then that is not science. But then they also can't get a job. That's a problem. So then we have to figure out a way. So this did happen, because at that point of time, I got a contract from Hindustan Aeronautics Limited. They asked me to do something, and I was not at all aware of what is it actually. It was something which was very, very new to me. So this was something called attitude and heading reference system. This also, I think, by the way, is a very important part in unmanned aerial vehicle. Okay, is a part of the navigation system. So the contract actually came to me. It was a very small contract. They wanted to build up an algorithm which was not known to them. They were buying the equipment from, I think, Thales, France. So this was important. That's what was put in most of the aircrafts. They wanted to make a cheaper version, not with the fiber optic gyros, but it was with the MEMS gyros. But that required a very good estimation algorithm. And I said, okay, I will try it out. I told that I will learn from scratch, and I started. But then that's the first time in projects, I said all PhD students who want should come. So I think 3-4 guys came. And then we started thinking. Sorry, my throat is bad. So we started building it over time, and then we got some idea, but then we found we need a Jacobian. Jacobian is partial derivative metrics for the dynamics of the aircraft. They say HAL said we can't give it to you. Okay, that's a confidential thing for every aircraft, the dynamics which goes behind it, because that can be actually used by enemy to ensure that they can improvise on the missiles which can shoot down this particular aircraft. So I was refused. And then I need to do something. So I started from scratch. I started with Muhammad is the one person who wrote a thesis in 1969, I think. It was on adaptive Kalman filters. I started with that. And then I learned and I figured out, yes, something can be done. And then by tweaking around with the parameters and everything, we could build up a system which can learn on the fly about the dynamics. And it was a very good filter. Ultimately, we even got a patent on that. That was the first effort which we did with the student. So students said, sir, we can start a company with this. None of them ever having the job. They were always worried about the job. Okay, go ahead and do it. And they actually applied for funding support from a technology innovation hub, which was in IIT Hyderabad. And they wrote the proposal. I stopped writing the proposal actually. Everything, most of them is being written by them. And once they wrote the proposal, we submitted, we got the thing. Okay, it was very unique, so we were very happy. But one condition was that we have to start a company, a startup. And that's where the things were actually go haywire. Then I thought that it is a very big problem, because whoever is going to be the director, managing director, or whoever is going to be the CEO, he is always on the toes. Secondly, in the startup, normally what happens is people will tend to work in such a way so that the evaluation gets increased. Once the valuation is very high, then you sell off the company and make your money and go out. You don't have a passion for technology there. I said there is something wrong. And also then I need to supervise who is going to work there and how to ensure that all PhD students will actually have a stake in that. I started studying about what kind of system model of the business can be taken up. Unfortunately, IIT Kanpur does not allow a faculty to have a non-profit foundation directly. Okay, so we can only go for a regular kind of company under faculty entrepreneurship policy. So we did that, but then how to operate it. So I started studying about all across the various kind of organizations people have created. So one of them which I came across was Carl Zeiss. I think Zeiss all of you do know. They actually do ultraviolet optics for EUV lithography machines which are made by ASML. They are the pioneers, they are the only one who does it, it's a monopoly. They also do a lot of military optics. You might have also got Carl Zeiss lenses in your mobile phones. They do a lot of medical stuff. But then amazingly their trade shares are not traded. Then I started looking for why organizations are successful, why they fail. And at the same time, I think I learned about Boeing. Boeing actually got burst because of the MBAs were hired essentially when McDonnell Douglas was actually merged with it. And they were looking for the share prices, not for the good engineering. And that's what ensured that Boeing is going to go downhill. And they had one after another, said 737 getting crashed. There is a big aircraft where two battery fires happened. And so, in fact, now it is to an extent that a lot of people don't fly 737s. People have more faith on Airbus A320 actually, or 321. So, it was just basically they were always worried about share prices, not about the good engineering. So, it was one very good example. It became a nice case study which is now being taught to engineers. Then, at the other end, the Carl Zeiss is a very old company. It was started by a physicist and a technician. Technician's name was Carl Zeiss, by the way. And Ernest Abbe was a physicist. And Schott, S-C-H-O-T-T-T, was a chemist who started a glass company at the same time. This was in Jena, Germany, East Germany actually. And then when Carl Zeiss died, Ernest Abbe actually formed a foundation. And they never worried about money, they were worried about building up very good microscopes. Okay. And they started making glasses, spectacles, making money from that and feeding into making of microscopes. And they become pretty good in that. They still now sell a lot of these imaging systems. So Ernest Abbe then created something called Carl Zeiss statutes. Okay, the rules under which the company will be operated. And that's when the first worker cooperative actually came into action. This was, I think, one which I know. This worker cooperative model has been already in existence for a long time. Later on, I discovered in India also three of them. Okay. So one of them is, I think some of you might have taken their coffee, India Coffee House. Other one is Ural, which is in Kerala, which is a construction company. And then there is a Nilanso, which is a software development company in Hyderabad, which is also a worker. Basically, the people who work, they actually own it. Remember, in the business case model which I have told you, the labor which is being taken as a raw material is no more a raw material in this business. It is the investment into the business. Carl Zeiss also did exactly the same. They said profit will never ever be given as a dividend. It is always going to be always distributed for the common benefit of all the employees and common people. Later on, it was only employees. Still, they do this actually. That's why their attrition rate is very small. All employees participate in the decision-making process. And I got impressed by them. Then I heard of Mondragon in Spain. Very similar model. It was a failed companies actually, which was then taken over by the workers. Government gave the money and they became a worker cooperatives. It's a network of cooperatives now, running very stably well, very old. There is attrition rate is very small and they are competitive actually. It's a competition among cooperatives essentially. That's the way it actually operates. Then gave Ecosia, which is also in Germany. So I also started exactly the same way. So we formed a cooperative. It's called Yarna. Yarna.com. You can go and see, actually check it. So we do a lot of products actually building on this. Rajiv is aware of it, and maybe someday he will also start something in REC there. And Manoj will surely allow him to have a faculty and enabled company with 10% equity or whatever is equity required by REC. So that their people will get motivated because it's theirs. They have to work for it, not working for somebody else. Okay, this should happen, I think, in all academic institutes. Now, amazingly, Carl Zeiss supports 5 universities in Germany. All their doctoral students, their professors, their research, all the research output goes back to Carl Zeiss. There's the ecosystem they have built it. There's a pretty large fraction of their revenue actually goes there. And they are always on the edge because of this. So that's an amazing thing. You don't have to ask money from the government. You are self-sustainable. Okay. So companies are all owned by the people who work. So we started this and we thought, okay, we'll do the first product, which is going to be our AHRS system, Attitude and Heading Reference System, which we built for HAL. Because 3 years had passed, that lock-in period was over. We improvised on the design and then filed a patent, which we have got the patent, I think, some 2 months back. Is there with us now. So we are now building up the hardware product, which has to be sold to anybody who's integrating UAVs. Okay. And then we will probably migrate to navigation system development with that. So the way we work is we don't give salaries. That's a very amazing thing. Because remember, work here or the labor or the efforts is nothing but the input, investment to the system. So we give something called work equity. So the way we decided that every month, everybody has to tell what they are working on daily basis. We have a daily synchronization meeting. And at the month end, everybody says these many work hours I have actually contributed. We always evaluate the efforts. And then through a consensus process, we figure out how many work hours should be allocated to everybody. So you can't, if you do ask for more, people will reduce it to make it genuine. If you ask for less, people will increase it because that way they are trying to encourage you because they have to increase their work equity's value. Okay. So the work equity will get assigned every month based on the amount of effort being put in. And every we just contribute, we build up the product. And whenever the surplus is there or money available for disbursement, that is put for option. So you have to surrender your work equity, work hours, and then get the share in your whatever is being put for the option, that particular surplus block. Okay, that's the way we do it. This is a pretty stable system. Game theoretically for everybody, being honest is the only strategy. Any other thing, you will be a loser in long run. Short term gain, you may get it, but then you will be out of the system pretty soon. Okay. So pretty stable system. And then we started working on it. And then we actually incidentally found a very massive contract, about 12 crore rupees, which we got recently. So it is 6.5 crore which has come to IIT Kanpur to build up the product, and remaining came to the company. And that's where without any nuts and bolts attached. Is money so that the company can grow and become even bigger. So we have been working on 5 or 6 products parallelly. We take a lot of interns. We take any PhD student who joins now in the lab will automatically become part of this Yarna.com. He works on a product which will be marketed. So roughly 70% is for value generation, 30% is a greenfield research for future. That's the way we do it. So we have been working on a peer-to-peer application now, building on that. AHRS system. We have been working on a digital communication system for metros and RRTS, which has been funded by a private company, by the way. And we aim to actually, probably in future, very soon, the next RRTS going from Kanpur to Lucknow, most likely bidding for that. We'll be able to build up a system before this actually tender comes up, which will take about a year now. Because they have to do a lot of land acquisition and everything, then only the signaling system, when it comes, it will be quite late. By the time we should be ready with the product. Okay. So we have been working on 6G systems. Basically, this is again a cooperative project which we have written into DOT with a company actually. Okay, this is again going to come. This is where we have to build what we call network in box. So multiple 6G controls central core which will be built, which can be distributively deployed instead of currently the way we have a central one. So it will be extremely resilient, and we'll be using peer-to-peer networks technology to cooperate or to essentially coordinate all the actions between them. But the good thing which I found, people are happy, whoever is working, and nobody blames. So if you want to earn more, you have to contribute more. So even the interns who come in, they also actually earn work equity. If they give a work, they contribute meaningfully. Okay, if they only do some so-so work, they don't get anything. Okay, but if they actually start contributing, they start earning also in that. But of course, earning is not on monthly basis as of now, because our first revenue cycle is not complete. So normally now I always love to share this particular model with all academics in all academic institutions, people who are there, because that could be one way you have to solve the problem of placement. So currently placement, working for somebody else who is going to make profit based on your work, your labor, and you will be paid minimum possible as far as possible. And there are so many people who are there in the labor market, so prices will go down certainly. It's a demand and supply gap issue. So supply is being increased by a lot of engineering colleges, demand is still the same, you will get less salary. So it becomes, at some point of time, engineering will become non-viable. Nobody will do engineering. That's what is happening now. Seats are going unfilled. So best is essentially be your own master. Be your own, you have to be the owner of the company, and you should also work in the company. That's the way it should be. So I think this is something which you can emulate. Please do get in touch with me if you need help in this, if you don't understand how to operate. So I would love to explain it. Okay. But this can be a game changer, especially you can attract a lot of PhD students because they don't have to bother about what job they are going to get later on. They don't have to go and touch the feet of people to get a job. They don't have to go and then please somebody. See, I know there is a lot of maramari to get an academic job nowadays. Jobs are less. You have so many PhDs. So PhD should have to be absorbed in the industry. There is no other option. And secondly, now PhD will be more meaningful. You will not do it some simulation, something, and do something so that you get a thesis. You said, forget that thesis is secondary. First of all, my product has to be there. I have to make money because I am the owner of that part, owner of that company which is working. So I think this should actually make a lot of change. So I think this something which is extremely important for all of us. Okay. So this is something which I wanted to share with all of you. And now I will, probably it will be now interaction. I am opening up. So even if you have a technical questions about wireless communication, don't bother. You can actually ask me, and I will try to give whatever is under my understanding which is there. Okay. And you need not do the same products which I am doing. Typically, this model is very suitable for R&D companies. But if you can go into production companies, then you have to build up slightly differently. Okay. Remember that I told you three, Nilenso, ICH, India Coffee House, and Uranungal. All three are three different kind of companies. Okay. They are cooperatives actually. Amul is also a cooperative by them, but it operates in a different fashion. Okay. Agricultural cooperatives similarly can be formed. But they essentially work for the benefit of the whole society. Now, you have all heard of Israel. Okay. Israel, when it was actually started, when it was formed, the first thing which formed there was cooperative, which was called, there is a nice name for this. Yeah, I'm slipping this particular name. Okay. So they actually formed a lot of these villages. So they do a lot of their defense production, a lot of agriculture. So these are all owned by the people who are working. So they also stay in the same village. It's a community-driven thing. So this is what was the essentially backbone of Israel And later on, they came with the private capitalism, privately owned community companies, which came much later actually. Okay, so but this has been a very successful model, and I'm really impressed by the progress which has been made by the people. Ultimately, it's all about happiness of a lot of people.
That is, sir, kibbutz. Kibbutz.
Kibbutz, right? Kibbutz.
Yes.
Kibbutz has
Kibbutz.
been the backbone for the Israel. Okay. In India, probably I have not seen such a thing happening. Mostly, what happens is it's being always hijacked by some politician and it makes it a private property. Okay, because people, the owner, the participant themselves don't know what are their powers and how they have to exert their strength. That's very important, which of course in technology can certainly be done. Okay, so uh, let's open it up. So I have actually spoken a lot. I would now love to take up. You must be having a lot of questions about it, and I have a lot of experience to share, but I think I will stop it. And it's better that you people talk now and let me respond, or even other people can respond. Manoj is there, ma'am is there. She can always respond. Okay. So yeah, it's all floor is open.
Sir, very first question. So I want to just know something, because I am very much eager about knowing the future prospects of UAV. In fact, what I feel that different applications, various applications are still to be explored in this area. Recently, I heard about a taxi, single person taxi, using UAV. So, is that research is also going on at ID Kanpur, or like that? Can we proceed further?
Yeah, maybe then somebody might be doing it, but I can tell you these are called autonomous vehicles. So drone for me nothing but a aircraft which is autonomous.
Yes,
Okay,
sir.
so Airbus A320 can run in autonomous mode. It can act like a drone. Or 737, both of them are having that capability. They can be remotely piloted. Only thing is that once you do a remote piloting or autonomous piloting, so drone whenever means it's either remote piloted or it's autonomous. Both ways it can be done. Okay. So even bigger aircrafts, so big thing what happens is you don't have to carry the person there. So lot of safety parameters you can take out from the aircraft. Okay. Safety certifications, lot of subsystems which you built for safety, that can be taken out, the cost goes down drastically if it's unmanned. Okay. Especially in warfare, every pilot, so pilot ejection seat, pilot pressurization system, all that is extremely costly. And we lose a pilot, we lose a trained person, for which a huge cost actually goes into the thing. If the pilot can remotely do it, nothing better than that. So you reduce cost drastically, that's the reason. We know about aircrafts, both helicopters as well as what we call normal fixed wing aircrafts. Okay. So missile is now is a very good example of a drone in that sense. Missile if can be remotely piloted. Normally missiles are not. You just normally put in the coordinates and missile just passes through. It just now uses this what you call either GPS thing. GPS nowadays of course can be spoofed. You must have been already seeing those problems happening a lot of uh, airports. So we use something called one of the I think very important research which is happening now is in GPS denied environment how to build up high precision navigation. That is something which now is a race which is happening. Whoever wins it first will be the winner ultimately.
Yes.
So people have been doing with what we call optical systems using that, basically cameras and other thing, using local cues to figure out your coordinates. Maybe using distributed small towers around the ground, from there picking up the signal, or having what we call our patent is very similar. We actually have multiple MEM sensors put across the aircraft. We collect all the data and we start fusing them in an efficient way in a microcontroller. Okay, and we learned about the dynamics of each particular point where the MEMS sensor has been mounted. It's a gyroscope, accelerometer, and magnetometer, all three. Okay, are normally used. There is also another complication which is there, which is normally drones people normally don't even bother about. These are called gravity maps. Okay, so gravitation is different at every point on the earth and in atmosphere. So when I actually put a missile which has to be guided and which has to be landing within say 1 square meter precision, okay, to kill a person or to kill a target, I even need this gravity maps to be fed in, which are then used in the computation for the navigation actually. Okay, so this is one area, and then of course autonomous vehicles are already going to be there. Aircrafts, that's what drones are being we are trying. So you just plan everything, do path planning, everything, you leave it after that. It goes autonomously. There have been a case where your photograph of an enemy is being actually put in, the guy drone goes, it searches for the person, whoever is matches, it will kill him. Okay, that also has come in. But these are all autonomous modes. So they have to be very dynamic, they have to control it, but it's a very complicated thing because the AI based systems you cannot take risk. Even a slight face mismatch and a wrong person gets killed does not make sense.
Certainly.
Okay. So you lose the equipment, you actually create more basically a problem for yourself. So if you want to hit it, you have to hit in first instance itself, you have to do it correctly. Trains are already autonomous. I can give you Kanpur Metro, for example, can work autonomously. You don't need anybody. It can actually work without a driver, but because people will not ride in Kanpur if the driver is not there. The driver is actually intentionally put. It is in fact one of the best metros in India as of now. It is the first one which is a moving block signaling based system. And by the way, it uses Wi-Fi. Okay. The drones also similarly can actually be coordinated together, can put in. One of the problems with the drones is they need consume a lot of power because they have to do a continuous thrusting of the volume of air as we put down in downward direction. So they can get a lift. Okay. So maybe if we don't have a very high speed drones, in that case the balloon based systems will be better off. I think some companies now building it in India because this was a requirement of the defense. So they have a balloon which is built with hydrogen, which is the cheapest gas which you can get now. Okay, helium is costly by the way. Helium is also very limited in supply. It only comes from Canada, some from deep mines. So normally if you release it, it goes up in the air. There is very limited supply for that. So you put that hydrogen thing and you have to have some kind of buoyancy control so that you can move up and down this drone. And then you have only propellers for moving it around. So now with the same battery, same power, you can actually go for much longer thing and even you can do silent operations. Currently these drones are, most of the you have only seen the one which are flying, which are very agile. But silent drones will be required and the balloon based drones are extremely efficient. With much less battery, they can sustain for very long period. But of course, buoyancy control is one of the issues there. So this is same thing which is used in submarines. So the submarine can go down and up in the sea. Okay, so volume of water which they shift, similarly volume of air which is being shifted has to be changed. So there has to be inner chamber where the pressure has to be continuously updated so that the level can be changed. Earlier there was probably a challenge, so people went only with quadcopter thing or a helicopter or a fixed wing aircraft which are fast moving drones. But now I think those will also be coming up. Taxi thing also I think will be possible, but we have to look at the safety in the space. So if it falls, certification issues will be there. As a person, your private thing you can do so far you don't harm anybody, but it is still risky. It's like a single person airplane or 2-person or 3-person airplane. Okay. So, but drones normally will consume much higher power. Okay, but they don't require a taxiway. Or there can be even hybrid thing where you have a drone plus it goes a vertical takeoff aircrafts which can be there. Efficiency is the only issue because they consume tremendous amount of energy because you are not on a solid surface. But a better option will be, for example, is a what we call these are the vehicles which actually thrust a lot of air in the downward direction, but they also consume a lot of energy because of that. Okay. So I think the fixed wing aircrafts are better off. for the energy consumption. Or balloon-based systems will be another good option.
Yes, sir.
In fact, people have been now thinking if balloon-based things can come up. They call it we think is a seaplane or something they call it. There is a specific name for this. So they can be used for transporting a lot of goods. They can become a good replacement for ships.
Recently, this service has been started in Delhi for only tourist purposes. Recently, just
So it's a small aircraft. It's a small helicopter, basically, quadcopter. So it's as good as a helicopter service.
Other question is that if I talk about, I have little bit worked in underwater communication also. So what I feel that actually the whale, the fish, even it cannot go beyond 500 meters. The best scuba diver do not go beyond the 40 meters depth.
Hmm.
Whale goes maximum up to 500 meter. Even light doesn't go after 1 kilometer.
Hmm.
There is no light after 1 kilometer. And the average depth of the marina trench is that is 11.5 kilometers.
Right.
So rest purpose there where there is no light, there are a lot of wealth is there, and we know that the Earth is only one third of the total Earth. Say land is to one third of the total Earth, while two-third of the Earth is water. So lot of resources are there inside the water which are still to be explored. Lot of flora and fauna is there which has to be explored. So what do you think that the underwater drones have the future? And what should be their technology, since the lot of water pressure should be there, battery consumption is another problem, communication is also a problem because there is saline water, lot of water columns are there, lot of pH value, temperature, depth, lot of things are there. So
Electromagnetic waves cannot be used there. Right.
yeah, I know. See, sonar, only sonar waves works. So is that area where still I think many of the researchers has to go?
It has to be commercially viable. See, doing academic thing is fine, but it has to be commercially viable. It is possible. Hydroplanes have been built for fast transport, but they are not for deep sea thing. Deep sea, the problem is the extreme pressure which goes at that depth, because water has a higher density than air. Okay. Organisms actually over time has evolved. See, nature has a solution for everything. So through a natural selection process, evolutionary process, organisms are able to survive even those depths, but they have evolved in a different way for that environment. So evolution's only objective is the gene pool. Gene should actually propagate. So gene is selfish. So genes get selected in that fashion. So we don't know whether we will be able to reach there or not. But the question is, if it is required, certainly we can evolve the technology with time. We have to figure out how to actually take care of higher pressures, how to take care of buoyancy. If the buoyancy is not there, we can make a reverse hydroplanes.
कौन सा ये ना कौन सा है
Hydroplanes can actually go in such depths, but they cannot sustain there. You can just fly through that depth, that is possible. Okay, currently, but then the buoyancy control is one of the basic problem bottleneck there. So currently it's only done for military purposes mostly. People do some kind of a dredging to collect the nodules, but that actually also leads to a lot of damage to our ecosystem. So my advice will be don't even touch the sea. Okay, maybe Earth will get destroyed if you do that. There are already a lot of damage which has been done to the ecosystem, so we should not do it unless it is required. Probably it is not required for all of us being happy. Ultimately, only objective we can say is we live and we die. Only objective for humanity is so that when the earth is going to be destroyed, when the sun will expand as a, it will expand like a giant actually, red giant we call it. So that time earth will get destroyed. There is no chance that we will get, so only way we can survive is we have to move to some other planet. So all technology should be directed in that way. So at least our progenies at some point of time will be able to move with all our Noah's Ark essentially has to be built in space. Okay, but that is also not indefinite. If the Earth is, if there is a, if the whole universe is pulsating universe, someday it's going to call us back to that singularity again. If it is not, we don't know. Okay, we actually don't know what happens to the universe. There are a lot of theories around it. So that will be the objective. So short term, I think being happy in your life is the only objective, and everybody should be around you, should be happy. We should not fight. So why we should worry about even tomorrow we will have food or not? So worry of the food, your shelter, clothing. Okay, I think your good friends. That worry should be taken over. That's it. That's the only objective as of now, which I can perceive.
Thank you,
The
sir,
rest
for your
everything
nice.
is, of course, people can keep on talking. It does not make matter actually.
Thank you, sir. You are too satisfied person. You are very simple and certainly your words are very nice. I understand that thing, sir. Thank you, sir. Thank you.
Sir, there
Any
is
more
a
questions
question
from any
from
other audience? Do you want
no,
to?
there is a question from Chilaika Sudhamani. She asked, what are the various challenges you need to address while using UAV in 6G?
Yeah, one of the problems in 6G is what we call multipath interference, which happens. Okay, and specifically, if you start, for example, I have got this problem. This is actually the problem which, as a Yarna.com, we have to solve, but not in the beginning. When we are going to make something for a maglev, the signaling system, which is going to say run at 550 km per hour. Okay, and at that speed, communicating between train and the wayside equipment is extremely tough. So people normally think it can be done through 6G. Okay, now continuously maintaining channel characteristic between train and the wayside equipment, because it is a safety critical equipment system actually. So signaling information, what normally happens is train always tells the controller that I am at this location as of now. And controller based on that always gives the information back that you can move this much distance before your speed should become 0. Now maintaining that reliability at such a high speed is the biggest challenge in 6G. Currently there is no solution. We have been working with beam steering based systems which continuously steer and lock with the when the train is moving very fast. Satellite people have tried, but when you are putting it in underground tunnel, then it becomes a different problem. We are using then leaky fibers based systems. Kanpur Metro, by the way, does not operate at more than 80 kmph, and it uses Wi-Fi system. It uses latching and delatching between various Wi-Fi access points. So we probably will be able to push it to 200 kmph with Wi-Fi, which is without latching procedure. 6G system also we have to essentially do something in the latching mechanism and only use a physical layer, so that without that latching delay should not happen between base station and the mobile station. So you can move from one base station to another one, and all these base stations should cooperate together to move it to one single command center, the data which is going to control the traffic. So that's one example which I have, which is already a product problem in my hand, which we have to solve and give it, so that the maglevs will be using our own signaling systems there. Okay, and it should be a fail-safe system. I think first we are doing 80 kmph, which is doable, and then 160 kmph for RRTS, rapid rail transit systems, has to be done, and which is a challenge, and for which we are now improvising. We have actually removed, for example, the layer 2, where the association used to happen between a base station and the access point, a client and the base station, but not 6G, it's Wi-Fi. Ultimately, we have to migrate to 6G. Currently, 6G is not permitted for this use in India. So there is no spectrum for CNPN, has not been still released. Okay, so they are currently doing the study for this, because what happens is 5G and 6G systems, the band which they use has interference with the aircraft systems, so they cannot be used around the airports. They also interfere with the satellite based systems actually. So those spectrums have to be released, and we have to be told that now we can actually use those bands. So that's one challenge which I see. Then when you move very fast, you have to do pre-coders, have to be dynamically and very fast changing thing, so that you can compensate for the channel imperfections. This problem also has not been resolved so far. We don't know how to do it actually. We have to engineer the system. It cannot be done through simulations or writing papers. It has to be done in actual hardware. Okay, so we are already on it as of now. I think there are many other people who must be doing the same thing. It has a lot of business sense because high-speed train operations will actually depend on this. We do have optical systems which can operate for this kind of thing actually. But it has to be done through machines. Humans perceiving the optical signals and doing cannot operate beyond 120 kmph. So that's I think bottleneck speed for all our trains. Indian trains don't move faster than that because we don't have a radio-based signaling as of now. So that's something. And now coming to UAV, UAV is a very mobile thing. Keeping it stable all the time, optimizing the matrices, the transfer matrices. Mostly you will be using MIMO systems everywhere. Multiple input, multiple output antennas. Okay, on both receiver and transmitter side. So you have to keep on compensating for the channel thing. So that actually also means you have to very frequently send what we call training symbols. So that you can estimate the channel and send it the information back. So that the P coders can be, or the compensators can be continuously tuned. So if you're too fast, you are going to spend too much of bandwidth on this continuous tuning. If you are too small, too sluggish, then I think it's going to pretty much work very fine. Till 80 kmph, it's fine, but after that, it's going to be a problem. So that's one problem which I know of as of now. You can explore that. Secondly, there's a lot of people work about 6G, but they don't talk about the backend network. So backend it connects to the internet. Backend, there is a lot of optimization which is required, especially for roaming handovers. Okay, and then of course routing dynamically, handling multicasting traffic. So for that, doing it through distributed algorithms is feasible, but now people are mostly focusing on if they can actually use machine learning techniques to train it. And so basically machine learning system will learn whenever they are offsetted from the optimal operation, and they will try here and there and will pick up the correct operations actually. That's the one way of doing it. These are again projects which have been funded, but not has come in deployment as of now. We even actually don't have a 6G operating in India. 5G is there, but 6G is not there. Yes.
There is only one other question from the listeners, that is, can UAV be used for stabilizing network for disaster relief operation during post-disaster period?
You can certainly do it, but don't use one which is going to have rotor blades, which is continuously rotating, because that will create a lot of RF noise. Okay, and it will also consume a lot of battery. Your operation time will go down. So best is to go with a balloon-based system with the, of course, thrusters. Okay, so that you can actually keep it at one place for a longer time, and then they can use as a relay. So your most of the power will now get consumed in the relay, not in maintaining the UAV in the air. That's where you have to essentially do it. It's not a short term, it's a long term mostly. And especially disaster recovery sites, this can be useful. In fact, there is another technology which you can use, which we call peer-to-peer system. Okay. So your mobile to mobile, actually you can talk with Wi-Fi direct or Bluetooth. So it is possible to use something called disruption tolerant networking to build up a messaging system, which can work even when the backend network is not there. So mobile to mobile based networks actually can be automatically created on the fly. So DTN systems, but these are actually currently illegal in India. So you cannot form it. So apps are still available. You can try it out for your own experience. But government does not encourage it because they cannot be put under surveillance when it is required. So criminals can misuse it. That's the reason. Okay. But DTN is pretty much heavily used in military. Because they sometimes don't depend on the backend network. They have to relay it from one to another handset. So this is, I think, not openly acknowledged or something, but this is there. Also used by, I think, people when they want to go against the government and want to have agitations and government shuts down the networks. That time this kind of networks do come in use actually. But this capability does exist on all our mobiles. So in disaster recovery thing, this systems will be extremely good if they can be used. But I have not seen anybody working on for disaster recovery application using DTL. Well, I have not seen any paper. People must be working it. You have to search for it. I should not say that people are not doing it. They must be. It's an obvious solution.
Thank you, sir. I think it was a nice questionnaire. Dr. Arun, कोई और क्वेश्चन है?
No, sir, there is no other question from the participant.
Then please proceed according to as per
हाँ,
procedure.
नहीं सर से एक क्वेश्चन मेरा जनरल हम पूछना चाह रहे थे सर, ये जेनरिक एआई का क्या फ्यूचर प्रोस्पेक्ट्स है, मतलब वो क्योंकि
See, what happens is, I know since I have graduated at that time, I have seen a lot of things came as like, now I have found solutions to all the problems. And after a few years, we found out this is not the solution to all the problems. But those things never died, they still existed. Okay, they exist. So every technology has its own role. So AI is not complete thing, but AI is also not something without which which will not exist. It's also not going to be there. It will keep on existing, coexisting thing. Remember, it's a biomimicry. Most of the engineering is nothing but mimicry of the already existing biological systems. And as you create that, you are also evolving as a human being. We are all evolving. As our new generations will come, we die, new people will born. So they will all, our genetic selection will ensure that we evolve. Okay. Evolve to the, who are going to be fitter for the new environment. So this is a race which will keep on happening. So there is nothing like that AI will all the time will exist. AI is nothing but, because see, there is a one fundamental question which I also don't know the answer. Whether the consciousness is a function of structure. That's a fundamental question. If this is true, your machines can become consciously aware. My intuition most likely is this is not true. Okay, but this can be, I may be wrong. So take it with a pinch of salt. So this is an open question as of now. So if machines can become consciously aware, they will be like any other organism. So we are also like machines in that sense, created from, we are molecular machines created by chemistry. Okay. And we have evolved in such a way that we die, we bond, people bond, and we evolve, we become better and better, fitter and fitter for environment. Okay. And continuous evolution happens. So AI also the same thing has to happen. If you make a machine, make a program there, with that it can't sustain. It has to evolve. Otherwise it will die off. So it has to become part of a self-sustaining organism. Unfortunately, you have to still make chips, you have to still make computers. AI cannot do it. Okay. So it's all about organism. So they will become part of us. They will be essentially our extended organs. It will be like that, most likely. So in fact, I think a lot of people do say, I'm not sure whether it's true or not true, that we are all nothing but part of a much bigger organism called Gaia theory, I think. GAIA theory is called. So the earth is itself is a big organism. We are small organs within that participating. The way in our body we have a lot of organs and cells are moving around. So we are like those cells moving around in the earth organism. Okay. So some part of the our earth will die off, then it will regrow. So it's a regenerative organism which is there. We are already part of that big organism. So AI will also be part of that. So it will evolve, it will learn, and so far we can do it, but there is a limit. You cannot go more than that. There is a fundamental limit.
I agree, sir. I agree with you, sir. Because AI is just a mechanism where the training is always given to the, you can say there is no conscious, only the continuous training is the data training is there, and hence it becomes better and better.
It may build up a consciousness, this is possible, but this basically people figured out how the brain operates. It has neurons. They tried copying it and it was able to do something. So we built up machines using that same neural structure. We created layers. We still don't use generalized mesh. For example, I don't use my brain thing. Okay. But it is fine. Maybe someday when the person is going to die, we will cut open his head and we'll take the brain out, put it in a jar. We'll collect all those and that will become our neural computer.
Maybe possible. Be possible in future. I agree, sir. I agree.
There is a company in Australia, I think, which is already working on this.
Sometimes it is horrible also. How the mind of a person is being kept in a jar with some chemical and being later
It's a neuron, it can do neural computing. So far, you can give nutrients. But it is the exactly same human being who has died or not, we don't know. So some of us may feel it's the same human being we are keeping in the jar.
Really.
Or it's only a cell. If a brain dies off and brain again being enlightened, again done, will it be the same person? Will it be a different person? Most likely, all memories which are there in the neural structure, in the cells or the strings which are there, in the weights which are there in the neural structure.
Then there will be further questions. Can we connect the minds? I mean to say connect.
Maybe, we may not be, we don't know. I think a lot of it is open.
That is open.
So, see, only thing which I will always tell my students, a lot of them do ask me how the research happens. I always say research is nothing great. Anybody can do it. You have to have certain discipline. You think of a question or a problem which you want to investigate. You start thinking about, sit down and think about it. Don't do anything else. Okay, do it for 1 hour, half an hour, whatever you can do, at least half an hour. And after half an hour, whatever has come to your mind, if something is there to jot it down in your notebook and keep it. Next day again, do the same thing.
That's the nice way.
Day after day after day after day. Do it for 6 months, 8 months, 9 months. As you are going to do, you will find out, you will start gaining insights. You will figure out, okay, I should investigate this, I should investigate this. And you will now build up all the requirements, prerequisites to understand, gain the insight. And you will get clarity. That's what is research essentially. What my hypothesis is that when you do this on daily basis, your brain's neurons get rewired. Your brain's neural computer is now specifically trained to solve that particular problem which you are trying to solve. And ultimately you start
बता रहा है देखो ये चीज बता रहा है कि रिसर्च वर्क कैसे करें आप
Certainly, research work ऐसे ही किया जाता है. This is the right way how the research working is being done. Whenever you are thinking, you are getting some idea. Even in case of your sleeping, also, Isaac Newton used to do it when he was sleeping, or even Alan Turing. I have also read him. When he was sleeping, he got various ideas and he got it and he jotted down on the pen and paper. Same thing happened about that Benjamin structure calculate also. So whenever the idea comes in your mind, you have to just put it down on the paper and keep it on exploring further and further. So once you will have
hypothesis on this research process.
yes.
So, okay. So one is this, you try every day, your brains are rewiring. That's one hypothesis. Second one is that anything which you see or which you read is not actually one thing. There are a lot of small things put together. That's what build up an understanding or an insight. So when you try on one day, you actually gain an insight, but it's on something which is very infinitesimal, very small. Next day you can try, you can actually open up, you remove one layer at a time. And when you remove 1,000 layers, you see the thing which is hidden behind those 1,000 layers. That become visible to you.
Yes.
Okay, after 1,000 days. So that's the reason why it has to be a constant thing. It cannot be in spurt. So it's not like an exam, you just study. Maybe that's not a study, that's a memorizing. One night before the exam and then spitting out on the exam and you get some marks. But you don't gain insight. So that's the reason why you have to, when you study, study means everyday thinking about. And every problem you should be able to figure out a way to solve it. Even if you don't know how to make a solution, you don't know that anything. But when you think about it, you start understanding it. Slowly it happens. but you have to give it a time. So you have to have a patience for that. There's no magic. I think it is very difficult unless I have a lot of background being already built, because of which I can deduce the answers. This is true for any problem. This is true for any problem. And remember, what research you do is not important, what solution. Ultimately, what problem you are facing and what is the consequence of that is what is more important. And that's what should drive all your efforts. For example, say I am going to create an UAV which will create a communication backbone for something. Now that creating a UAV, creating a backbone, creating a communication is not important. What's the scenario for which you are going to figuring this thing as a possible solution? That is more important. And for that scenario, you have to list down all possible solutions which are feasible. Then find out the best solution. So you may figure out that UAV may not be the best solution. Okay. But in some scenarios, UAV may be the best solution. So normally our research should be driven by day-to-day problems which we face. So we should not be too far away from the reality, because if the moment that happens, you essentially then start acting as if you are doing research, but you are not doing it. Okay, and it is doable by everybody. Even a kid can actually do a research. You don't need to do a PhD for this. It's only about, it's the way you live your life. Research is essentially is nothing but a way to live your life. That's the way I always say. But that's what I've learned over so many years after doing PhD. This is only small thing that I need not do all these things. I was already knowing this thing when I was a kid. So I'm back to zero again. So I started from zero and I'm again back to zero.
So cool, sir. So nice, sir. बहुत अच्छे. This is really nice to interact with you. So thank you, sir. Thank you. Dr. Arun, please.
So Manoj, one request, if possible, try to have at least one or two tech cooperatives being spawned in your organization so that you can actually see the change. You can start the change. Your directorship may be over by that time you start getting the fruits, but that's fine. At least you should start.
Certainly, sir. I will do it and you will get the results, sir.
So thank you everyone. Thank you very much for everybody for patiently listening to me, even when I was off the topic, but I was talking in general.
Sir, it was interesting to talk with you, sir, to interact with you. And maybe the different, maybe sometimes we have deviated from the main topic. But even then, research is a parameter which can be applied on any particular domain. So the thing is beneficial to all of us. Thank you, sir. Thank you very much.
So thank
Really,
you very much. Thank you.
thank you.
Thank you, sir, for joining us. I think, sir, next session will be at from 8 p.m. There is a tea break for 20 minutes. So all can leave and rejoin it by 7:50.
Hello. Hello.
Recording in progress.
Welcome back, everyone. We now proceed to the second technical session of today's Faculty Development Program. It is my privilege to invite Dr. Arun Pratap Srivastava, Professor, CSE Department and Dean IQAC and Research Collaboration, Lloyd Institute of Engineering and Technology, Greater Noida. Dr. Srivastava brings with him, with over 2 decades of academic experience, international exposure, multiple patents, and more than 3400 citations on Google Scholar. Dr. Srivastava continues to be an inspiring force in research and innovation. Sir, we request you to kindly take over the session and guide us with your expertise.
Yeah, thank you so much for giving the opportunity to at this platform. Firstly, good evening to all of you. And today I am presenting my topic is the counter UAV techniques in the modern era. Unmanned aerial vehicle, counter unmanned aerial vehicle techniques in the modern era. Uh, just a minute, I just share my screen. Yeah, I think visible the screen. Hello.
Yes, sir.
Okay, thank you so much. Thank you. Now, basically, what is counter UAV techniques? Now, in this scenario, in this situation, the defense system are using the unmanned aerial vehicle because there is no loss of our any defense person, and that is the most important thing. And counter UAV techniques involve a multi-layered approach of detecting, tracking, identifying and neutralizing unauthorized drones through a combination of sensor jamming and kinetic uh, or directed energy system. Common methods include using radar. By this method, we just identify the uh, different drones. Radar, RF scanner, and cameras for detection, and employing technology like signal jamming, GPS spoofing, net guns, lasers, or high power microwaves for neutralization. Now, first thing is what is the UAV drones, and this is a unmanned aerial vehicle, and this is this flying machine controlled by the remote controller or by the phone or tablet. You can use GPS, preland path, And there are different types of drone we are having, like hobby drones in a small size, very cheap, easy to fly. This type of drone we just can use in the videography and other things. And the commercial drones for inspection, mapping, delivery. The system, courier system is also will use this type of drones in the future. And next is the industrial drones in the large size, long flight time, and most important thing, defense system, military drones we are using in the defense, that are advanced sensors, long ranges. Now the question is, why UAV are popular? Just only because of easy to operate, cheaper than airplane. Helicopter cost and the airplane cost is too high. But at this situation, we using the simple some number of lakhs in drone, can fly in small spaces. We don't use any large ground. We don't use, just you can fly in a small space. And UV used for the aerial photography, monitoring crops. In the agriculture system, we are using everywhere, not in everywhere, the maximum spaces uses the in the agriculture. And the package delivery, search and rescue operation, uh, like in the disaster condition, we just search the person or another things and rescue. And next is the scientific researches. Then why UAV can be dangerous? Drone can become threat when they fly close to airplane or airports. Definitely airplanes and airports के पास अगर वो fly कर रहा है तो definitely it will be dangerous for us. Spy on sensitive places, carry illegal items across border. That is a more challenge in this scenario. Fly over crowds, causing accidents, try to enter restricted airspace like military zones, government buildings, etc. And we can use the protests or high security events. How to detect the and detection overview. What are the detection overview? Detection means the finding the drone early, even if it is small or flying low. Modern airspaces need multiple sensors because drones are very small size, made of plastic or lightweight material, low flying altitudes, slow flying speed, quiet motors, ability to hover and fly through urban areas between buildings. And we are having a number of techniques by which we can detect the system. Radar detection. Radar sends the radio waves bounces off object. Radar detects the reflection. How radar help works in day or night. Covers long distances, detects movement and height. And what are the challenges behind radar? Small plastic drones reflect very little radar energy. Birds can look like drone. Urban environment cause false signal. And the second next method is that radio frequency detection. How it works? Many drones send signal between drone and controller. Radio frequency sensor listen for these signals. What are the benefits? Can identify drone band, sometime model, helps detect to pilot location, works without seeing the drone. That is the most important thing. Without seeing the drone, you can work out on that. And what are the challenges? Drones with autonomous flight may not send signals. Some criminal drones use signal hiding techniques. And next is the electro-optical cameras. How it works? High quality cameras zoom in on the drone. Operators visually confirms the object, and the benefits are the very clear identification, helpful in good daylight, useful for evidence collection. And what are the challenges? Needs line of sight, does not work well in fog or night. That is the most important point here. Electro-optical cameras cannot work in the fog and the night. Next is infrared detection. This is a very useful methods in this scenario. IR cameras detects heat signatures, useful for night monitoring. What are the benefits? Drone motors and batteries emit heat, strong for low light environments. And the challenges, very small drone produces little heat. Background objects can confuse sensor. And the acoustic detection. How acoustic detection? Use multiple microphones, listen for unique drone sound pattern. And the benefits, works in place where radar fails. जहां रडार हमारा वर्क नहीं कर रहा है वहां हम acoustic डिटेक्शन के थ्रू जो है हम ड्रोन को आइडेंटिफाई कर सकते हैं. Good for small and slow drones. And what are the challenges behind it? Wind noise, traffic noise cannot detect silent drones because it detects sound. And the wind noise is also a problem. Next is a combined detection system. Most modern CUUAV counter UAV system combines radar, radio frequency cameras plus artificial intelligence because one sensor alone can make mistake. Multiple sensors, definitely there is a higher accuracy. Helps confirm the drone in real, not a bird or balloon. If we are, that's why controlled UAV when we are using, then these type of problems we can eliminate it. Identification and tracking. Recognizing what type of drone it is. Checking if it is authorized or unauthorized. Understanding its purpose. We can identify it. And what tools we are using, and flight pattern analysis, radio frequency signature analysis, AI image recognition, and drone registration database. Tracking helps answer where is the drone going, how fast is it moving, is it heading towards a critical areas, where might the operator be. Tracking uses radar tracking, visual tracking, AI motion prediction, and GPS-based geofencing. Goal of counter UAV, that is a protect airspace. We can just protect our airspace, protect people, and protect critical sites, reduce accidental crashes, stop unauthorized operations, support law enforcement and military security. Because if anyone hit through the drone, then we can protect using this type of drone counter UAV. Response techniques. Response categories depends on level of danger, place where we are using, airport, stadium, base, local law. Categories of responses: electronic responses, physical capture methods, security and coordination methods, warning and radiation methods. Electronic response, that is jamming, that's high level, disrupt communication between drone and controller, cause drone to hover, land. Hover in the air means in the air in one place, we can stop it. And use of jamming is strictly controlled by government because it can affect other signals like phone, radios, and GPS. Electronic responses sends fake GPS signal. Drone get confused. Drone may fly to a safe zone on land safely. That it's a very important point here. And also legally restricted and used only by authorized agencies. Physical capture, net guns. Shoots a net to track the drones. Drone falls slowly, no damage to surrounding. हम अब ड्रोन के थ्रू जो है नॉर्मली जो है हम हिट कर सकते हैं। अगर जैसे अब नॉर्मली जैसे पिस्टल से हम फायर करते हैं, तो उस तरह के पिस्टल को भी हम यूज करते हैं और बिल्कुल सटीक निशाने पे जाकर के उसे हिट कर देते हैं विदाउट एनी मैन। नो डैमेज टू सराउंडिंग, गुड फॉर क्राउड एनवायरनमेंट। ऐसे लोकेशन पे जहां पे बहुत भीड़ भाड़ है, वहां पे आप अपने ऑब्जेक्ट को आइडेंटिफाई करके उसको डायरेक्टली हिट कर सकते हैं। एंड फिजिकल कैप्चर इंटरसेप्टर ड्रोन्स, स्पेशल ड्रोन दैट कॉज सस्पिशियस ड्रोन, यूज नेट्स और सेफ इंटरसेप्शन मेथड, useful where electronic solution are restricted. And physical capture, that is net parachutes. Some system suits need nets with small parachutes, ensure safe landing, used in urban area. High energy system and laser system use a focused beam of energy, can disable drone parts, mostly military. High power microwave systems affect drone electronics, useful for drone swarm. And non-tech responses like geofencing, pre-programmed no-fly zone inside drone, prevent drone from flying near airport or government buildings, helps reduce accidental threats. Security team responses, security teams may trace the operator, secure the area, use communication tools, and notify law enforcement and evaluate the threat level. Warning system and public alerts, siren alerts. We can use siren on screen alerts for control rooms, instant messages to police, and air traffic control. These are the UAV applications: aerial photography, cinema and filmmaking, border monitoring, critical infrastructure like power plants, dams. These are the dangerous area where we can use the CUAV. And police and rescue operation, package delivery, because in the future definitely all the courier companies is using the package delivery. And आपको बताओ कि जिस हम लोगों ने जब स्टार्ट किया तो हमारे साथ जो है ये ST माइक्रो इलेक्ट्रॉनिक्स ने भी वर्क किया। ST माइक्रो इलेक्ट्रॉनिक्स ने हमारे साथ वर्क करके जो है ये आइटम्स डिलीवरी के लिए काफी वर्क किया। हम उनके साथ बेंगलोर में भी काम किए जो है, और उसमें डिलीवरी, हाउ टू डिलीवर द पैकेज, बहुत ही अच्छे से हम लोगों ने उसको कंप्लीट किया। और ये डेफिनेटली all courier companies can use this type of drone. Scientific research, mapping and surveying, infrastructure inspection, public events, stadium को भी हम लोग मॉनिटर कर सकते हैं, VIP प्रोटेक्शन जोन्स, एयरपोर्ट, prevent collision with aircraft, monitor runway and airspace. Military bases, protect operations, prevent surveillance. Critical infrastructure, power station, oil facilities, and also in railway. Public event, sports event, concert, or VIP visits. In these situations, we face this type of threats. So by these methods, we can protect all the things from these methods. Counter UAV system architecture, that is this basically it's some main components. A full CUAV system includes detection sensor, multiple detection sensors we are having in the system, communication network, AI based software, tracking tools, decision making center, neutralization equipment, human operators. Multiple sensors are needed. Why multiple sensors are needed? Because drones vary in size, material, flight pattern, altitude, speed, sound, radio frequency emission. No single sensor can detect all drones. That's why multi sensors we required for the detecting the drone. And these are the challenges in this system. Technical challenges: drones are becoming smaller, faster drones are emerging, autonomous drones that don't emit signal, drone swarm. Legal challenges: many countermeasures required special permission. Airspace regulations vary by country. Risk to civilian communication. Operational challenge: urban clutter, high population density. These are the major challenges where we use this facility. Future of counter UAV, future technology: AI-based real-time drone classification, faster 3D radar, cloud-connected drone ID systems, nationwide drone monitoring networks, automated responses system. And long-term trend is smarter, safer stopping methods, drone flight licensing, stronger geofencing rules, better cooperation between countries. And basically, this is summary. Drones are helpful but can cause risk. Counter COB system protect airspace. Many technologies work together, means the radar, radio frequency, cameras, AI, all these we are using in the counter UAV. Responses must be safe and legal, and the future system will be more automated and intelligent. Thank you, sir. Hello. Now I have completed the presentation. Have you any question?
Hello. Hello. My wife is there.
Yes, sir.
I have a one question for Arun sir. That's why I called. Sir is there on the call? Hello. Hello. Hello, Arun sir.
Any question?
Yeah, sir. Good evening, sir. Hello, Arun, sir.
Vivek ji.
Sir, actually, for anti-drone
Yeah.
technology
Mm-hmm.
that you have discussed, sir, at what frequency is required to target the drone should be jammed, or any other technology is required to jam the drone, those who are not in required territorial area and other things. Because the anti-drone technology now nowhere, I think, in the commercial purpose, rather no one is using this. So
No, sir.
very
Defense system is using these facilities.
yeah. Different systems are they are using, but how means what frequency and what technologies they are targeting to that stop the drone.
Yeah, basically, it's combined radio frequency, AI and radar system, सबको include करके, because multiple systems we are using in this scenario. क्योंकि अगर हम कोई भी इस तरह की सिचुएशन क्रिएट हो रही, कोई ड्रोन अटैक हो रहा है, तो वहां पे उस टाइम पे डायरेक्टली जो है किसी भी कीमत पे जो है आपको उस ड्रोन को रोकना होगा, और उसके लिए जितने भी सेंसर्स को यूज कर सकते हैं वो यूज करते हैं, और इसमें सारी चीजों को कंबाइन कर लेते हैं, रडार, रेडियो फ्रिक्वेंसी एंड एआई ऑल. यस सर.
Okay, sir. Hey, that frequency, which particular frequency, if you want to design any anti-drone system, suppose, and then what different component is required? Suppose I want that my student should build one project in which they have to design the anti-drone system. So, what will be the initial step? What frequency we need to target? And what will be the range and other components that if I want to know? If any information from your side, it will be a great help.
Okay. बेसिकली फ्रिक्वेंसी, जो कॉमन फ्रिक्वेंसी हम लोग यूज करते हैं, दैट इज 2.4 गीगाहर्ट्ज एंड 5.8 गीगाहर्ट्ज बैंड पे. तो बेसिकली अभी एंटीडोट सिस्टम जो है इसी फ्रिक्वेंसी को यूज कर रहा है और जिस पे वर्क चल रहे हैं. बिकॉज कि ये जो सिनारियो है जो फिर इसका एंटी ड्रोन का या एंटी मिसाइल सिस्टम का, तो इस पे तो अभी काफी वर्क चल रहा है, लेकिन इस चीज में काफी सक्सेस मिली है. आपने देखा होगा जब ये ऑपरेशन सिंदूर के टाइम पे भी काफी यूज किया गया इसे. और जो फ्रिक्वेंसी है वो 2.4 गीगाहर्ट्ज एंड 5.8 गीगाहर्ट्ज बैंड पे है.
Okay, thank you.
यस विवेक जी. बिकॉज इसी रीजन से इन काउंटर यूएवी हम लोग जो है मल्टीपल सेंसर यूज करते हैं, बिकॉज कि कई ऐसे पॉइंट्स पे जाकर के कुछ ड्रोन ऐसे हैं जो डिटेक्ट नहीं हो पाते हैं, इसलिए हर तरह के सेंसर्स को, मल्टीपल सेंसर्स को फ्यूजन करना जो है इम्पोर्टेंट है. देन बिकॉज ड्रोन साइज में वेरी करते हैं, मटेरियल्स उनके वेरी करते हैं, फ्लाइट पैटर्न्स उनके वेरी करते हैं, स्पीड वेरी करती है, साउंड वेरी करती है. तो इस कंडीशन में जो है मल्टीपल सेंसर फ्यूजन्स के थ्रू जो है कोशिश की जाती है कि सक्सेस हो, पूरी 100% सक्सेस मिले. जो
apply function also on top of the full 240 megahertz that you have here, right? Let's say 520 some other traffic. So you move to this 240 or there, that would be another traffic in secondary subchannel. And you have to account what is that channel pattern purchasing, and we have to model that, and definitely this will better help in the efficient management of the spectrum. It understand performance, it understand return of the deployment, but I don't have a that number to select. We have to assume certain conditions, and this was moving, and then that's but relatively true.
Mr. Rajesh, your question is how effective are current detection system in identifying a small, low altitude drone that often resemble birds are on radar. तो जो काउंटर यूएवी बेसिकली जो हम यूज कर रहे हैं उससे हम ये सारी जो हमारी जो प्रॉब्लम्स हैं जो मेरी हम जो प्रॉब्लम्स हैं कि वेरी स्मॉल इन साइज में भी ड्रोन्स वेरी स्मॉल इन साइज लो एल्टीट्यूड और स्पीड and sound, these are the major problems. That's why we are using this type of system. We are using all the methods like radar, radio frequency, artificial intelligence, and the multiple sensors we are using for the detection of these problems. Yes, sir. Yeah. One more question here. What is the maximum altitude of UAV to enhance the performance? Basically, the maximum altitudes that is ranging from 400 feet to for standard commercial and recreational drones to cover over 50,000 feet, approximate 15,240 meters for specialized and military drones. Maximum is the currently ranging from 400 feet for the standard commercial drones, UAV drones.
यार शांत बसा रे. ते मोठ्यानं जरा आवाज वाढव.
Yeah, sir, one more question we are having. Basically, the main challenges in distinguishing friendly, commercial, and hostile unmanned aerial vehicle in urban airspaces are primarily due to the technical limitations of the current detection system. तो वहाँ पे प्रॉब्लम्स रहती हैं कि कोई डिटेक्शन सिस्टम ऑलरेडी नहीं यूज हो रहा है. द लैक ऑफ रॉबस्ट रेगुलेटरी फ्रेमवर्क्स and the physical characteristics of the urban environment. These are the main difficulty the system faced. So, any more question? Yeah. Question: which counter UAV technologies are expected to dominate future defense strategy and why? Okay. And dominated by multi-layered AI-powered controlled UAV, CUAS system that is integrate various detection and neutralization technologies. Alongside the increasing use of directed energy weapons and autonomous counter-swarm drones. This approach is driven by the need of comprehensive and adaptable defense against increasingly sophisticated and autonomous drone threats. Yes, sir. Any more questions, sir?
In UAV, is there any application of radio environment map in UAV? Sir, is there any application of radio environment?
Yeah, definitely. Systems we are using different UAV means radio frequency or anything else also. Sir, again, please, what is your question, sir? Please.
To you,
Yeah.
sir, is there any application of radio environment mapping in UAV?
Yeah, so there
Means
are
I just
some
know that
applications are available, but
or TV space are applicable or not.
sir, definitely applications are available. This what we want to know, but currently we have no idea about it.
Okay, sir.
Applications are available. I'm sure applications are available.
Because I have gone through few journals that
Yeah.
UAV and TV white space related journals.
And these applications, basically, see, UAV systems basically using in the aerial photography, cinema, filmmaking, border monitoring, critical infrastructure, agriculture, police rescue, and package delivery. In the all field, we are using CUAV applications, and definitely it's available, sir.
Okay, sir.
And
Thank
the
you.
more question, I think, sir, what advancement are being made to counter drone swarm, and how spread our current defense system for such attack?
Okay, sir.
Swarm focus on artificial intelligence and the multi-layered defense systems, moving beyond traditional kinetic methods. And while current defense system, I think, are increasingly capable, and the evolving nature of drone warfare means that remains persistent and significant challenges. I think uh, these are the advancement of.
Okay, sir.
Oh, because okay. Okay. Any query? Please ask the question. Thank you, and thank you.
Thank you, ma'am.
Okay, ma'am.
Recording stopped.